Okay, this leads us to our last step, which is to write your answer verbally and make sure that it makes sense to people that are reading. Not everyone is a mathematician. If you're going to be an engineer one day, you need to be able to solve a problem and talk about it with the people you work with in ways that they can understand it. All right, or maybe it's a client that you're trying to explain, your solution to. So if you look at the original question here, we're just trying to figure out the rate in which the fish tank is rising as it fills up with water. We figured out, for example, for step 11, it's 0.05 meters per minute. So for step 12, the height of the water level is increasing at a rate of 0.05 meters per minute. It's pretty small, but 0.05 meters, I don't know, that just doesn't really seem. We can answer it better, okay? So here's the better answer. We know that there's 100 centimeters in a meter, right? So 0.05 meters would be 5 centimeters. So the height of the water level is increasing at a rate of 5 centimeters per minute. So that makes a lot more sense. So for every minute, this fish tank is rising 5 centimeters. And I think that really answers this question thoroughly. Anybody can read that answer and it would make sense to them what it means, right? So that's it for example 1. We've answered it in the 12 steps necessary to get to the right answer. Let's look at example 2, which is the ladder falling, and we figured out that the ladder is falling at a rate of negative 0.41 meters per second. Let's answer this one. The top of the ladder is falling down at a rate of 0.4 meters per second at time t equals 1. So if you go back to the picture, which is what I typically look at time t equals 1, this ladder is falling at a rate of 0.5 meters per second. Or sorry, 0.4. So can we answer that better? Well, again, there's 100 centimeters in a meter, so you might say approximately 40 centimeters per minute. Okay. Centimeters. It's per second. Okay, let me change that. Something wasn't right there. So if you think about it, 40 centimeters per second is pretty fast. It's a lot of centimeters in a second. For this one, I don't know, zero point 0.4 meters. People can make sense of that. That's about half of a meter, right? The reason we did in the last example, 0.05 of a meter, it's easier to think about 5 centimeters, okay? This one's a little bit bigger, so you could leave it either way. But at any rate, you can see that the ladder is falling pretty quickly, okay? If it was a meter per second, you can imagine how much faster that would be. So that's it for this example. We figured out how fast the top of the ladder is falling as it slides away from this wall. Make sure you get those units right as well. Notice I had to double check to make sure it was seconds, not minutes. Meters per second. For example 3, we had water pouring into a conical tank. We want to figure out the rate in which the water level is rising at a particular when the height of the water was 5 meters. In fact, I need to put the units there. So for step 11, we had 3 over 2 pi is equal to dH dt, but let's write that out in a sentence for step 12. The water level is rising at a rate of 2 over 3 pi meters per minute when the water level is 5 meters high. This is around 0.477. You take this number and convert it to a decimal, meters per minute. Again, if you want to write that in terms of centimeters, it would be about 47 centimeters per minute. Now, that's actually not a whole lot, okay? After a minute, just 47 centimeters. Seems like the ladder was falling at a quicker rate. But anyway, at any rate, it just gives you a more conceptual understanding when you go back and look at the picture. The rate in which this is rising, about 47 centimeters per minute. So more or less about a centimeter per second. Okay, so that's it for example 3. Just write out a sentence that makes sense and you're done. Example 4, we had the coffee draining from our coffee filter into the pot. And we're ultimately trying to figure out the rate in which the coffee level is rising. For step 11, we got 0.7. So we just need to take that and answer it in a sentence that makes sense. The coffee in the pot is rising less than 1 inch every minute, about 0.7 inches per minute. Okay, and that's going to answer this question. This level, the level of coffee in this pot is rising is less than 1 inch per minute, so about 0.7 inches per minute. So if you were to sit here and watch at this particular point in time, the rate in which this is increasing, it won't even be increasing an inch in a minute. So again, we just want to write the sentence out that makes sense to the average person, and we've done that with this question. That's step 12, writing an answer that makes sense. This is it for related rates. We've done 4 examples, 12 steps. Okay, I know that's a lot of steps, but if you notice, every step is simple, and I think when you first learn this, the best way to learn it is to learn it step by step, one at a time, especially if you're doing an assignment. And after a while, you will be able to just do all steps at one time, no problem, since you were able to master each individual step. If you have any other questions about related rates, let me know.